Okay guys, so 2.2 we're looking at the equations of tangent lines and linear approximations. So we've talked about tangent lines before, and this paragraph here you can take a minute to read it, but all we really need to know, it tells us everything we already do know actually. Down here, f prime of a, that's going to be our slope, okay, and then, because remember the derivative gives us a slope, and up here it does say that the slope must be a number. So remember that. Then it's x minus a, and a is just our x1, just like we'd have in our point slope form. And then f of a is our y value. So we're going to be using that instead of the traditional slope-intercept form, like finding it that way. So here we go. It says, example 1, we want to let f of x equal 4x cubed minus 5x plus 3, and we're going to find the equation of the line tangent to the graph of f at x equals -1. So step 1, we want to find the derivative of this function. So you can use the power rule. Remember, we take the 3 to the front, 4 times 3 is 12x, and then we subtract 1, so 12x squared, and then minus 5. Remember that constant rule, the constant's always 0, so it's not even down here. Okay, step 2, once you find the derivative, you want to plug in your x value. So we want to plug in -1, just like that, and that'll give us 7. Okay, so this number represents our slope, because our derivative, once we plug in the x value to the derivative, that gives us slope. Okay, step 3, we're going to take -1, we want to find that y value. So remember, to find the y value, we just take -1 and plug it straight into the original equation. So f of -1, evaluating all of this, we get that to be 4, and that's our y value. So we have an x value and a y value, which makes a point, and then we have our slope. So if we plug it into this new tangent line equation, it's the slope times x minus our x value, which is -1, plus our y value, which is 4 in this case. So it'll look just like this. So the slope minus a -1 changes it to +1, and then we have +4 on the end. Remember to pause this anytime you need to take a second and figure anything out. Okay, tangent lines from a table of values. So we're given the differential functions f of x and g of x, and we're going to use the table below. So part A, it wants us to find the line, or the tangent line, of g of x at x equals 6. So to read this graph, here's our x value, is 6. So this would be like f of 6 is -3, g of 6 is 7, f prime of 6 is 2, g prime of 6 is -4. So all we need to know in order to make an equation for the tangent line, here are the equations here. So f of x, well, I changed these, they mean the same thing. I just changed one to look like g of x, so it wouldn't be as confusing. So we want to find g prime of 6 in this case. So g prime of 6 is -4, and then, so that goes here. Then we have x minus a, so x minus 6, that goes there. And then we want our g of a, so g of 6 is 7, and that goes here. So that's all you have to do for these. And then for part B, you're just using f of x, so we're using -3 and 2 this time. So f prime of 6 is 2, f of 6 is -3, so to plug that in, our slope comes first, which is 2. Then we have x minus 6 again, and now it's -3 instead of plus, because it's plus -3, which makes it minus. All right, next page. Using a calculator. So it says to find the equation of the tangent, or the line tangent to the graph of f of x equals x to the 4th plus 2x squared at the point where f prime of x is negative or equals 2, and then round all values to 3 decimal places. So I just highlighted this right here because that's our slope, and I don't want you to forget that, okay, because it's the derivative, so it's going to be the slope. All right, step 1, we want to find the derivative just using the power rule. So we'll take this original equation, find the derivative, which is going to give us 4x cubed plus 4x. Now, Step 2, it tells us that f prime of x, which is this right here, equals 2. So we're going to set it equal to 2. And now we want to get everything to the left-hand side. So we'll subtract 2 from both sides and set it equal to 0. Now I made a little note over here. It says graph this on your calculator and use the second trace option or feature to find your x-intercept. So that's what it means by using a calculator. So we can't factor this, but we can use our graph to find where it intercepts the x-axis. And if you do that, you will get 0.42385. And it says to round all values to 3 decimal places, so I'm not sure why she did not do that, but it's okay. It'll be more approximate anyways if let's do the 3 values, or the 3 decimals over here when we do the actual tangent line. So step 3, we're going to plug this x value in to our original function because we want the y value now. So we've already got the slope, we've got our x value, now we just need our y value. So plug it into the original and we get 0.39157. Now all we have to do is plug it into our equation. Well, the formula for our equation, or however you want to say it. So y equals, the slope is 2, and it's x minus this value. And if we round it to 3 decimals, 0.424, and then plus our y value, which is 0.392, if we round it up. And so that's how we do this. This is your final answer. Okay, example 4, finding a value for k given the tangent line. So this one's a little different. We do have these steps right here. So part A, I just went ahead and found the derivative of f of x. So in this case, k is a constant because we want to find the value of it. So it's a constant term, so the derivative is 0 anyway. So we'll just use negative x squared, and that gives us f prime is negative 2x. Alright, so step 1 is to equate the functions. Now what that means are these two functions up here. We have f of x and we have y. Okay, so we want to make those equal to each other, which is right here. Now, step 2 says to equate the derivatives. So we just take these equations and we find the derivative of each of them. We know that this side is negative 2x and this side is going to be negative 6. Now we can solve for x. So if we solve for x, we get x is 3, and that's our x value. Now, to find what k would be, if we went ahead and subbed this back in, it says solve and substitute. So we're going to solve or substitute 3 back in up here to step 1 to get k by itself. So when we do that, it looks like this. Now we're going to simplify each side and we get k minus 9 equals negative 17. That negative 17, if we were to cover up this part right here, so cover up this side, what we just did was we plugged in our x value to our original function, negative 6x plus 1, which gives us our y value. So the point of tangency, which is, it doesn't ask for it, but just so you know, it's our x and y value. So 3, negative 17 would be that point of tangency. Now to continue to solve for k, we just add 9 to both sides, and we get k is negative 8. So this is our final answer. Okay, example 5, we're not going to do it. We do not know how to find the derivative of a trig function just yet. I'm not sure why they included this in there because it was not covered in any of the previous sections. So we'll just skip that for now. Move on to the next one. Okay, example 6 talks about the normal line. So the normal line is the line that's perpendicular to the tangent line at a point of tangency. So, it says the function shown at the right is the graph of f of x equals negative 1/2 x squared plus 2x plus 1. So that's this parabola right here. So step 1, we want to find f prime of 3. So we need the derivative, which you can take the derivative here. So if you take 2 down, it'll give us negative x plus 2. And now we'll plug in that 3, and we get negative 1. This -1, remember, that's the slope of the tangent line at x is 3. So part B says to draw that tangent line to the graph of f of x, x is 3. So this line right here, that's going to be the tangent line. Okay, because remember, the tangent line just touches that point, and then, or touches that graph at one specific point. It doesn't actually cross it, it just touches it. So this is our tangent line if we were to draw it. Slope of -1. Okay, and then part C says to write the equation of the tangent line at x equals 3. So to do that, we need to find the y value because we know the slope is -1. We know our x value is 3. We just need this y value right here. And if we were to look at that, we could pretty much estimate that that's going to be 3 and then 2.5. So that's our y value. And we can just plug those in. So we said our slope is -1, and then we have x minus 3 plus 2.5. Okay? And then it says to find the slope of the normal line. So the definition of a normal line is the line that's perpendicular to the tangent line at the point of tangency. So at 3, because that's the point of tangency, we want to find the slope of the normal line. Perpendicular lines have opposite slopes. So since the slope of the tangent line is -1, the slope of the normal line is +1. And then we can draw that through here. So we start at that same point and go up 1 over 1, up 1 over 1. Same thing. So draw that line, and that's the normal line. Then down here it says to write the equation of the normal line and draw this line on the graph. So we already saw how it was drawn. And it says this is the same as the tangent line, but with a new slope. So we use the same point. We still use 3, 2.5. And that's going to just look like this. So this -1 becomes positive. All right, linear approximation. So we have just a couple pages left. We have a really big definition here to look at, or explanation. So I'll finish that on the second part of the video because this one's about to cut off. So part 2 will be up next.